video, I'll be explaining the numerical summaries of data. And what you want to learn in this video is how to use the measures of center, spread, and position. Yeah. Now, the measures of center, the first I'm going to talk about is the mean. What is the mean? The mean is the same thing as calculating the average of a data set. And the mean is affected by outliers. So it might not always represent the typical value. And how do we calculate the mean? For example, you can have something like A, B, C, and D as your data set. I'm going to provide an example in the subsequent slide. Then to calculate the mean, it means you have to add up the data set and divide it by the number of observation you have, which is going to be 1, 2, 3, 4. So this is the general method for calculating the mean. Secondly, we have the median. The median is the middle value in a sorted data set. So the first thing you have to do before you use the median is to sort your data set. It can be in decreasing order or in an increasing order. For example, you can have A, B, C, D, E. Then you look for the middle value, which is going to be C, and this is going to be your median. But in some cases, you can have it as even numbers or you can have it as odd numbers. In this case, we are having this as odd numbers, which is 1, 2, 3, 4, 5. But in the case where you have it in form of middle number, like example, you have A, B, C, D, E, F. In this case, you are having these two numbers in the middle. So what you have to do is to calculate the average. In the subsequent example, you will see how this is being done. And the last one is called the mode. Another name for mode is the most occurrence, the most frequent value in a data set. That is the mode. If you look at these three measures of center, the median is not being affected by the extreme values. And here we talk about comparing the mean and the median. This can be used to define the shape of the distribution. Anytime your mean is greater than the median, then you can confidently say that your data set is skewed to the right. In the previous class, we talked about skewness to the right, skew to the left, and symmetric. When your mean is greater than the median, then you can say that the data is skewed to the right. If the value of the mean is less than the median, then you can say that the data is skewed to the left. And lastly, anytime your mean is approximately the same thing as the median, then we can say that this is symmetric. In the subsequent example, I will give you some data sets and I will ask you to find the shape of the distribution. Also, we talk about the measures of spread. Here, when you talk about the word spread, we are interested in talking about the variation. And here we talk about the range, the standard deviation, and also the variance. When we talk about the word range, range is the difference between the minimum and the maximum value. So range, the formula for range is the max value minus the minimum value. This is the formula for calculating the range. And also we have the standard deviation. In our next video, I'm going to give you an example on standard deviation. Easily, this can be done using the TI-83 or 84 calculator. Now we have this example. The cost price of a product for 10 randomly chosen days is reported as given. If you look at the data set is already sorted, which is in ascending order. Now the question is find the mean. And to find the mean, we have several notations to find the mean. The mean can be represented as x bar, which is the same thing as saying 1 over n summation of your xi, where your I is from 1 to n. And in this case, it means the addition of everything you have, which is 24 plus 25 plus 29 up to the last value, which is 40, dividing this by the number of data sets, which is 10. If you sum up the numerator, you should have 3317 over 10, which is the same thing as 31.7. The next one is find the median. Now to find the median, in this case, we need the middle value. And if you look at this data set, we have even numbers, which is 10. So the two middle values are going to be, okay, the 5th and the 6th value. Or alternatively, you can do it this way. Cancel out the first one, then you cancel out this. You cancel out the second one, and you cancel from behind too. You cancel out this, you cancel out this. You cancel out 29 and 35, then you can get the two middle values. And the median are going to be the average of those values, which is 30 plus 32 divided by 2, which is 62 over 2, and that gives 31. The next is to find the mode. Now to find the mode, from the definition of the mode, it means the most occurrence. Looking at this, 29 appeared twice and 35 appeared twice. Other values appeared once. So the mode are going to be 29 and 35. And from the previous video I did, I told you when you have two modes, this is the same thing as bimodal. The fourth one is to find the range. From the definition of the range, which is the same thing as the maximum value minus the minimum value. So here, the maximum value is 40, the minimum value is 24. So the range of the distribution is going to be 16. And the last question is, what is the shape of the distribution? Looking at this, my mean is 31.7, and it is greater than the median, which is 31. If they're approximately the same, then it can be symmetric. But if you approximate this, this is approximately 32, which is greater than 31. Then I can say that this is slightly skewed to the right. So this is slightly skewed to the right. And here, in the next slide, we have that. Yeah, the next is the measures of position. Here, I'm going to be talking about the z-score. The purpose of the z-score is to tell us how many standard deviation data point is from the mean. So in the next video, I'll be talking more about the z-score. But here, we have the quartiles and the interquartile range. The IQR stands for the interquartile range. So the quartiles divide the data into 4 equal parts. Here we have the lower quartile, we have the upper quartile, and we have the median. So those are the things we have. So the median is dividing the entire data set into 2. The lower quartile divide the half of the data into 2, while the upper quartile divide the other half, the upper half of the data into 2. And here we have an example to show how to calculate the quartiles. Now looking at this data set, the first thing we want to do is to find the first and the third quartile. Now to do this, the first thing to do is to rearrange the data set. Yes, this is the first thing to do, because before you work with the quartiles, you need to rearrange the data set. And by rearranging the data set from the minimum to the maximum, we're gonna have we have 5, 6, 5, 6, 6, 7, 7, another 7. Here we have 8, 8, 9, 9, 10, 10, another 10. Here we have 11, 12, 12, 13, 14, another 14, 15, and then here we have 16, 17, 18, 19, and lastly we have 27. So the question is, find the first and the third quartile. Now for the first quartile, to do that you have to divide the data set into 2. Everything is 25. You divide the data set into 2, leaving out the median. So if you do that, the median is this 10. This is the median. You leave out the median. So you divide the data set into 2. This is the first half. This is 12 in total. And you have the other half of the data, which is from 11 down to 27. This is the other half of the data. Now, to get the first quartile, it means you find the median of this. And the median of this is going to be 7 and 8. These are the middle number, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is half. Half of 12 is the 6th value and the 7th value. So if you take the average of that, this should be 7 plus 8 over 2, which is 7.5. So the first quartile is represented as Q1. This is the same thing as the first quartile, equals 7.5. Secondly, we have the third quartile is represented as Q3. So you look at the other half of the data. What is the middle value? It's going to be the 6th and the 7th value, which is 1, 2, 3, 4, 5, 6, 7. These are the middle values. And the half of this, if you take the average of this, is 14 plus 15 over 2, which gives 14.5. So this should be 14.5. So now we've gotten the Q1, we've gotten the Q3. And the next question is the interquartile range. The interquartile range is represented as high QR. And the formula is Q3 minus Q1, which is the same thing as 14.5 minus 7.5. And that gives 7. Next, find the lower and upper outlier boundaries. I think these questions was repeated twice. Find the lower and the upper outlier boundary. For the lower outlier boundary, I'm going to use LOB. The formula is Q1 minus 1.5 IQR. And this is Q1, which is 7.5, minus 1.5, multiplied by the interquartile range, which is 7. So this gives negative 3. And for the upper outlier boundary, I'm going to use UOB, upper outlier boundary. The formula is Q3 plus 1.5 multiplied by the interquartile range. And Q3 is 14.5 plus 1.5 multiplied by 7. And this gives 25. So the lower outlier boundary is -3 and the upper outlier boundary is 27. The last question is list all the values that are classified as outliers or extreme values. You see, the outlier are values above the LOB. So the values above the UOB or values below the LOB. Now, for the LOB, do we have any value below it from the data set? Do we have any negative values? If you check this, no. There's no value less than -3. And for the UOB, do we have any values? This should be 25. Do we have any values greater than 25? Yes. And what is the value? We have 27 to be greater. So the outlier is going to be 27. And choosing the right measure. For your data type, we have different measures are appropriate. It can be continuous or categorical. And for the data distribution, skewness and outliers can influence the choice of measure. And lastly, for research question, which is going to be done in the subsequent videos, the specific questions you are trying to answer will guide your selection of measures. Thank you very much for watching. See you in the next video.